Hello everyone. The topic for today's lecture is variables and expressions. The term expression refers to just the combination of operators and operands. An example of expression would be addition of two numbers or subtraction of two numbers or multiplication of two numbers. Whenever you compute the result of an expression, you can do two things with it. You can display the result onto the screen using the print function call or the output display box. Alternatively, you can store the result of an expression into a variable which will enable you to reuse the result for future computations. In today's lecture, I'll be reviewing the operator precedence ordering because a lot of people find it non-intuitive to understand the ordering in Python. Following that, we'll learn more about expressions. We are going to learn a new term called variables and how to assign the result of an expression into a variable using the assignment operator. It's never too late to learn about bugs. Learning how to program in a particular language, that is, learning the syntax of the language, is a relatively easy task. Good debugging skill is the more challenging skill for you to pick up. Throughout the course of this semester, we are going to learn how to write good programs and also how to debug bad programs. Finally, we'll be learning about variable naming conventions. Let's get started by reviewing operator precedence order. Recall that in the previous lecture, I mentioned that there are three major categories of the operators when it comes to precedence ordering. The first category is the mathematical operators. The second category is the comparison ones. And the third category would be Boolean logic operators. Within the mathematical operators, exponent has the highest precedence. Following that, you have unary signs, which is less intuitive, mainly because signs have higher precedence than multiplication, division, integer division, and the modulo operator, which is the percentage sign. After multiplication and division, you have addition and subtraction, and that's the ordering within the mathematical operators. Whenever you perform a mathematical operation, the natural follow-up task that you can think of would be comparing the result of the mathematical operations, correct? Hence, the ordering for comparison operators. Comparison operators include double equal to, not equal to, less than or equal to, and so on. When you perform comparison, your result will be a Boolean value, which is true or false. Hence, you have the Boolean logic operators as the final set of operators in the ordering. Within the Boolean logic operators, not has the highest precedence. Once again, that's not very intuitive. Following not, you have and finally you have the or operator. Sometimes it can be tricky for you to remember the fact that signs have higher precedence than multiplication and division. So I've come up with an example expression here which can potentially help you remember that signs have higher precedence. The expression here says 10 minus minus 2 integer divide 3. I'll be posing a set of questions as part of today's lecture. For each question, I'm going to prompt you to pause the lecture video and compute the expression using pen and paper and provide an answer in the comments section. Please make sure to follow those cues. So here is your first question. What is the result of this particular expression on the screen over here? Please make sure to not use Python interpreter to answer this question. Pause the video here and answer this question in the comments section. So if you got an answer as 11, then you had the correct ordering for the operator precedence. So I'm going to copy this expression and I'm going to switch to terminal because I'm on a Mac. If you're on Windows, please open PowerShell. I'm going to go into Python interactive mode by typing Python 3. If you're on Windows, you'll have to type Python. Once I'm in the interactive mode, I'll be able to verify the result of this particular expression over here. Before doing that, let's try to compute it by going through the operator precedence order here. There are three operators and three operands in this expression. The three operators are subtraction, unary negation, and integer division. And the three operands are 10, 2, and 3. So unary negation has the highest precedence. So you're going to first compute -2. Following that, you have integer division, which has a higher precedence here. So -2 integer divide 3 will give you the result as -1. Finally, you'll be applying subtraction. So 10 minus of -1 is going to give you 11. So let me go ahead and paste the expression here. As expected, Python interpreter gives the result of this expression as 11. Let me try to give you more examples for integer division here so that you can understand why exactly -2 integer divided by 3 would be -1. Let's compute 1 divided by 2. That's 0.5, correct? What would happen when I say 1 integer divided by 2? We'll be rounding this value down, so we are going to get 0. What about -1 divided by 2? That is minus 0.5. So -1 integer divided by 2 would give you -1 because you are rounding down. In a similar way, 2 divided by 3 would give you 0.666. So 2 integer divide 3 would give you 0. Because -2 by 3 will give you minus 0.67, -2 integer divide 3 will give you -1. Now that we have gone through the computation of this expression using the correct operator order precedence, I want to go through the two other incorrect operator order that you can apply for this particular expression. Let's say that instead of applying unary negation first, somehow you apply the integer division, which is not correct as per Python ordering. So I'm going to do 2 integer division 3, which will give me 0. So 10 minus of -0 is going to give me 10. Observe that we got a totally different answer by switching the order of application of operators here. What if I were to perform the subtraction first? So I'll get 10 minus of -2, which will give me 12. So 12 integer division 3 will give me a value of 4. So you need to be very careful with respect to remembering the correct ordering for operator precedence. Let me switch back to the slide deck. The next concept that I want to talk about is something which is called as short circuiting. I briefly mentioned that I'll be covering short circuiting in today's lecture. The question 2 which I want to pose for all of you is, what do you think is the result of this particular expression that you see on the screen here? Go ahead and pause the video here and compute the result of the expression without using Python interpreter and write your answer in the comment section. So if you got an answer as true, you had the correct result for this computation. Are you guys mathematical geniuses because you were able to raise 3 to the power 10th million and 2 to the power 20th million without having access to Python interpreter or a calculator? I'm sure all of you were able to find a shortcut, correct? So what was the shortcut? The shortcut was that the first part of this expression evaluates to true. That's because 1 plus 1 is equal to 2. That precisely is what is meant by short circuiting. Python is capable of following the exact same shortcut. So whenever you have OR as part of your expression evaluation, if the first half of your expression evaluates to true, Python is going to skip evaluating the second half of your expression over here. So I'm going to copy this expression and let me switch over to terminal. So if I run this expression, notice that Python is able to perform the computation instantaneously. What if I take the second part of this expression here and try to do the computation? That will take Python some time because it's raising 3 to the power 10th million and also 2 to the power 20th million. Turns out the second half of this expression is false, but if I were to run the whole expression, Python will apply short circuiting and will only compute the first part of this expression before the OR. Kind of makes intuitive sense. Why do you want to compute the rest of the expression if you already know that the expression is going to evaluate to true? So let me give you one more example here. What if I were to say 1 plus 1 equal to 2 or 4 divided by 0? Because of short circuiting, Python would not complain that you have a 4 divided by 0 here. If I were to switch the order around and say 4 divided by 0 or 1 plus 1 equal to 2, then Python will throw an error saying that you got 0 division error. Let me give you some intuition about the short circuiting which might cause problems when you write expressions. False or true is going to be what? That's going to be true, correct? False or false is going to be what? That's going to be false. So in order to generalize this, false or x will be what? That will be x, correct? Because of that reason, if I say false or high, where high is the string, I'm going to get the result as high, which doesn't really make any sense, correct? So you should always avoid having Boolean value on one half of your Boolean logic operator and have some other data type as part of the other half. Let me give you a concrete example where this will make more sense for you. Let's say that I'm trying to compute the expression 3 plus 4 equal to 7 or 6. What do you think will be the result of this computation? It will give you true, correct? That's because 3 plus 4 is equal to 7, so you're going to get true. What if I were to switch the order here and say 3 plus 4 equal to 6 or 7? You might expect that you'll still get the result as true, but that's not what will happen here. You'll get 7. Why is that the case? That's because the double equal to comparison operator has a higher precedence. So you're going to first perform addition, which has the highest precedence. After the addition, you're going to perform the double equal to comparison. So you'll end up with false or 7, and false or 7 is going to be 7 because you're comparing a Boolean value and an integer. Let me slightly change this expression. If I were to say 3 plus 4 equal to 6 or 8, you're going to get 8 as an answer, which doesn't at all make any sense. So how can you fix this expression? You'll have to type it out fully. So you'll have to say 3 plus 4 equal to 6 or 3 plus 4 equal to 7. Even better would be for you to use parentheses around both halves of the expression here, which are separated by or. That will make it very readable for somebody who's going through your program. So you need to get a good intuition of how to write out expressions fully in this particular example. That's because you'll be using expressions a lot when it comes to conditions and loops in Python. Recall that those are two exceptions for the in-order execution of control flow. Eventually, when we learn conditions and loops, we are going to be writing a lot of expressions. So you need to always make sure that you write the expression in an expanded manner and if required with parentheses. So let's go back to the slides here, and I'm going to start talking about other terminology when it comes to expressions. So far, we learned that expressions are mix of operators and operands. A lot of examples are shown here on the screen. Your operands can either be a literal or a variable. So let me define the term literal first. Literal just refers to a fixed value. Example of a literal would be integer, floating point value, string, and Boolean type. So let's switch between literals and variables in just another slide. Before that, I want you to just observe the literals that are there in this slide and observe the variables that are there in this slide. So this is literal and this is variable. So just like in mathematics, you can use variable names like x or y or z. In Python world, you can use more descriptive variable names like diameter, pi, num, count, and so on. So an expression can either be a mix of operators and operands where operands are literals, or it could be a mix of operators and operands where operands can be variables. So let's do a quick quiz here. I have 6 entries on this slide over here. Pause this video here and answer this question. What are the examples of literals that you see on the screen? So if you had answered with option 1, which is 0 integer, and option 4, which is true, a Boolean value, and option 6, which is string goodbye, then you had the correct answer to my question. So be very careful with Boolean values. If you have a capital T true, it is a Boolean value. Small t true would be a variable. It would be a very bad one, but it would still be a variable name. Similarly, capital F false would be a literal. Small f false would be a bad variable name. So let's talk about how we can assign the value of an expression into a variable. So we have all of these expressions which we can use as right hand side, and we'll be putting in the assignment operator, and on the left hand side we can use a variable name into which we want to assign the result of an expression. The right hand side is always going to be expression which will be evaluated first, and then you have the assignment operator, and your left hand side is going to be a variable here. So let's go through a set of demos to understand how variables work in Python. I'm going to go back to my interactive mode and I'm going to type a variable x. Let me assign a value 1 to it. So that's how you perform assignment into a variable. So I can simply say x equal to 1. After that, I'll be able to display x, or I can print x by saying print open parenthesis x close parenthesis. In Python, you can very easily reassign the value of a variable by saying x equal to 10. And now if I display x, you're going to see a value of 10 here. So how can I update the value of a variable other than performing reassignment? I can say x equal to some expression, and I'm going to say x equal to x plus 1. Please don't confuse yourself with the algebraic notation here. In Python, when you say x equal to x plus 1, the right hand side will get evaluated first. So you're going to evaluate x plus 1, which would be 10 plus 1, 11. And now you'll be updating 11 into the variable x here. So if I display x now, you're going to get a value as 11. You can have multiple variable names. For example, you can say y equal to 5. So it's important for you to get a really good mental model of all the variables that your program uses. Let me introduce to you an excellent tool for that. I'm going to go to the course website, click on Tools, and click on Python Tutor. Python Tutor is an amazing visualization tool for beginners who are trying to learn how to write code in Python programming language. So I'm going to click live programming mode. So I'll be able to type in the same expressions and assign things into a variable. So I'm going to say x equal to 2, y equal to 3, and I'm going to say z equal to x plus y. So the Python tutor works like a script mode. So if you have to see a particular variable's value, you'll have to use the print function call. Notice that when I called the print function saying print of z, that is going to be the terminology that I'll be using for the parenthesis. So I'll be saying print of z, of. So once I called the print function, an output box got displayed on the top right here, and you can see the output within that output box. So let's take a look at this mental model of variables here. For now, don't worry about the terms frames, objects, or global frame. Eventually, we are going to learn about those. Notice that you have variable names here and boxes beside them. You're going to see value of each of the variable names. In Downy book, you might see a different view here with respect to visualization. So if you scroll all the way down, you will find a drop box which says inline primitives don't nest objects. So if you switch that to render all objects on heap Python, you're going to see a different output here for the visualization. You'll see arrows instead of direct values into the variable boxes. Even though Downy book follows this visualization, I'll be sticking with the default view in Python tutor. Eventually, we are going to talk about what is the difference between these two views and what is meant by heap. For now, you just need to know that you can switch the visualization view here. So let me briefly introduce to you 3 examples of bugs. X equal to 2 is correct assignment, but phi equal to x is a bug. That doesn't make any sense to Python. So this is example number 1 of a bug. Example number 2 would be if I say z equal to x plus capital Y. That's because capital Y is a variable which is not defined. Example number 3 would be, let's say that I want to raise x to the power of y. Let me first print that by saying raise x to the power of y. And let's say that by mistake I am using the uptick operator, which does not refer to power in Python. Notice that you're getting the result as 1, which is not correct because 2 to the power 3 is 8. So you're getting an incorrect answer in option number 1 here, but Python is totally happy. So this is going to be a third example of a bug. I'll wrap up this video here. In the next video, we'll learn about 3 different categories of bug.